G'day, Year 10. How you going? Today, we are starting looking at non-right angled trigonometry. So last week we did a bit of revision of right angled trigonometry. Today is our first kind of time that we're entering into non-right angled trigonometry, and we're looking at the area of a triangle. Okay, now you've known the formula to calculate the area of a triangle since year 8, okay? You know that as area equals half times the base times height, okay? And so when you're calculating area with that formula, you need the base or the height, or both actually, to be able to calculate the area. You need the base and the height. Now, what if we do not know both of those things? Okay, so we know the base but not the height, or we know the height but not the base. Okay, in that case, we might know other information that can help us find the area of a triangle. And so what we're learning today is a new formula, okay, that will also help us find the area of any triangle. Doesn't have to be right angled, but it uses trigonometry in the formula. And basically, this allows us to find the area of a triangle even when we don't know the height of that triangle. We just need to know two sides of that triangle and the angle in between, which we call the included angle. So here's our formula here. Area equals half AB sine C. Now, a couple of things to notice here. You can see the formula has been repeated a few times. So you've got half AB sine C, you've got half AC sine B, you've got half BC sine A. Now, the reason why we repeated this several times is because which side or which angle is A, B, or C is actually totally arbitrary unless you're given the diagram with those letters there. So here I have a triangle. I could call this angle A, and then we call the side that is opposite on the other side of the triangle lowercase a. Okay, if I called this one angle B, then the side opposite it would be lowercase b, and if I called this one capital C, this would be lowercase c. So the lowercase letters refer to the sides, and the uppercase letters refer to the angles at the corner of that triangle. Okay, and you've got this sort of matching thing where capital A looks across at lowercase a, capital B looks across at lowercase b, and then capital C looks across at lowercase c. Now, there's no reason why I can't just change these so that the top one is now A and then the bottom side is lowercase a. Okay, so the reason why we've repeated this formula several times is basically because it doesn't matter which one's A, which one's B, which one's C. What does matter though is that you have two sides and then the angle in between them. Okay, so AB in this diagram that we've done here would be the bottom one and the left one here. And then the included angle would be C. Okay, if I used A and C, then the included angle would be B. Okay, that is the angle that is between those two sides. So if you've got A here, you've got C here, then B is the angle that is between those two sides. So that's the important thing. We don't need to know all these different formulas. You just need to know this one, okay, in the sense that you can just change which side is A, B, and C for any triangle and just use the one formula here. Okay, so that is our new formula. We just need to practice using that formula by substituting the right values that are in the question. Okay, so find the area of the following triangles correct to one decimal place. The area, the area is going to be equal. Okay, we're going to use this formula, half AB sine C. Okay, and now we're going to substitute. So it's going to be half times, it doesn't matter, or in this case, we're going to call the bottom one 14 because it's opposite capital A. But again, the order that you do 14 times 12 or 12 times 14 doesn't actually make a difference in the end. Okay, B will be 12, and then C is 57 degrees, so it's sine or times sine of 57. And we just pop that in our calculator. So we go half, okay, times 14 times 12 sine 57, and then pop that in. You can put a 12 times in front of the sign if you would like. Okay, but again, your calculator will recognize that you're timesing it. And then press equals, and we've just got to do it to one decimal place. So it's going to equal 70.44 dot dot dot, and then approximately equal to 70.4. We're going to ask ourselves, what are we actually finding here? That's right, we're finding an area. So if we use centimeters to measure the sides, it's going to be in centimeters squared. Okay, let's just do one more example. Okay, here we have PQR as our letters, but again, it doesn't actually matter. We can just choose which side is A, which side is B, and which angle is C. So we have two sides, and the included angle is 130. So area equals half times 8 times 11 times sine 130. Okay, that's all you need to do for these questions here. So let's do that. So half times 8 times 11 times sine of 130, close brackets, and we get 33.70 dot dot dot, and then that rounds to 33.7, again, centimeters squared, because we're finding an area. Okay, so that's all we need to do is we need to know this formula and recognize that it's a formula for area. And then we've got to be able to substitute the right values in for the sides and the angles to then find the area of the triangle. All right, good luck with the work today. I'll see you later.